All right, we've reviewed the definition and evaluation. That's just the same as what we did the first of our course. Now we get to go on to the new stuff, our multiplication and division rules. So my first two rules are that if I have a to the m times a to the n, I get a to the m plus n. If I have a to the m divided by a to the n, I get a to the m minus n. Let me show you an example of why that works. I will have a couple of these in your homework. I know it's a little bit of a pain to write it down, but I really only have two problems. So just humor me and write these ones all the way out. So if we have 7 to the 4th times 7 to the 5th. Well, 7 to the 4th is 7 times 7 times 7 times 7. 7 to the 5th is 7 times 7 times 7 times 7 times 7. How many 7s? I have 7 times itself how many times? That's 7 times 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 7. 7 to the 9th. So do you see why when I'm multiplying and I have the same base, I have to have that common base of 7. 7 to the 4th times 7 to the 5th really is 7 to the 9th. I'm saying I have 4 7s times 5 7s. Altogether, I have 9 7s. So if I'm multiplying things together and they have common bases, I add the exponents. Now, on the other hand, if I have 7 to the 9th divided by 7 to the 4th, I have 9 7s on top, 4 7s on the bottom. Well, my 4 7s on the bottom will cancel with 4 7s on the top, so I'm just left with 5 7s, or 7 to the 5th. So for these two problems, and again, these are similar to the two that I'll ask you to write out in your homework. When it says expand and simplify, I want you to write it all the way out, but I don't ask you to do it very often. X to the 5th, that would be 5 x's. X to the 7th, that would be 7 x's. Altogether, I have 12 x's, so it's 12 x to the 12th. 5 to the 13th, that's 13 5s. A little bit of a pain to write, but it's okay. 5 to the 9th is 9 5s. 9 5s on the bottom will cancel with 9 5s on the top, and I'm just left with 4 5s, or 5 to the 4th. So now that we have that rule, let's do a few more examples. Okay, these are just slightly more complicated than what we did before. We can only combine things if they have common bases. So for this first one, I have v squared, then I have v. What is just v? Good, that's just v to the first. That's like there's an unwritten 1 right there. So I have v to the 2 plus 1 plus 4 plus 7. I'm going to add all those common bases because they all have the same base. They're all being multiplied, so I add their exponents. On the bottom, I have v to the 3rd plus 5. So I'd have v to the 14th on the top, v to the 8th on the bottom. Now 8 of those v's on the bottom will cancel with 8 on the top. So I have 14 minus 8, and I get v to the 6th. Now for the next one, I've got more than one variable going on. So I have r to the 6th, s to the 4th, 13r squared s. So we have 13, r to the 6th, r squared, s to the 4th, s. You don't need to rewrite it, but I think it's helpful sometimes to do that. Okay, the r to the 6th and r squared can be combined. Altogether, I'd have 8 r's. And my s to the 4th times s, altogether, I'd have 5 s's. So I have 13r to the 8th, s to the 5th. Next one will have division. My negative 12 over 3, that's just going to give me 4. Then my r to the 4th and r to the 3rd. The r to the 4th is on the top, the r to the 3rd is on the bottom. So I have 4 minus 3 for the exponent on the r. 2 minus 1 for the exponent on the t. Remember that unwritten 1. Then u. So my final answer would be negative 4 r to the first t to the first u, or just negative 4 r to u. Last one, 25 over 10 simplifies to 5 halves. My x's, 3 on the top, 2 on the bottom, so 3 minus 2 are left. Y is just, there's nobody to combine them with. And my z would be 7 minus 1. The exponent would be 7 minus 1. Simplified, 5 halves, x, y, z to the 6th.